you have the summation of n divided by n cubed plus 1, and start from 1 goes to infinity. For this series, it's easier for me to use comparison test. You can also use limit comparison. Both of them are absolutely fine. It is easy to use the comparison test. Why is that? Because we can reduce the fraction to n divided by n cubed, or 1 over n squared, which is a p-series. In this case, p is equal to 2. It's more than 1, so you have a convergent p-series. Also remember that from algebra, since n values are all positive values, n cubed is less than n cubed plus 1. So if you flip this, you get 1 divided by n cubed plus 1 less than 1 over n cubed. Now, if you multiply both sides by n, you get n times 1, n times 1. And when you take the series of both sides, the summation of n divided by n cubed plus 1 is indeed less than the summation of 1 divided by n squared. By comparison test, if an is less than equals to bn, and if the larger series is convergent, you can indeed conclude that the smaller series is convergent as well. But this guy on the right-hand side is a p-series. P is equal to 2, as we mentioned here, and you have a convergent series. So by comparison test, this series is also convergent. So again, for this, you can use comparison test, limit comparison test. If you decide to use limit comparison test, use the exact same series as well. So let me write this guy down for you here. If you decide to use the limit comparison test, then you have the limit of an divided by bn as n goes to infinity. Suppose your an is basically the exact same general term that you're using for this series, which is n divided by n cubed plus 1. So on the numerator, you have n divided by n cubed plus 1, and on the denominator, use the p-series 1 over n squared as n goes to infinity. This becomes the limit of n squared times n divided by n cubed plus 1 as n goes to infinity. This guy becomes just 1. And since 1 is a positive finite number, by limit comparison test, the summation of an and summation of bn have the same convergence, divergence behavior. But since the p-series summation 1 over n squared is a convergent series, we conclude that our series, which is the summation of n divided by n cubed plus 1, is also a convergent series. So for the same series, I showed you two different methods in analyzing the convergence and divergence. You can use comparison test, which is basically you're comparing n divided by n cubed plus 1 to 1 divided by n squared. This is just a p-series, which is convergent. The larger series is convergent, so the smaller series must be convergent as well. Or you can use the limit comparison test. Either is fine. You take the limit of an divided by bn. As long as it's a positive finite number, it means that the convergence and divergence or the behavior of these two series is going to be the same. But since one of the series is convergent, this is a p-series which is convergent, you can conclude that the other series must be convergent as well.